In this video, we're going to look at the functional group carboxylic acid. Now, in a carboxylic acid, we have combined both a carbonyl and a hydroxyl on a carbon chain. So you're going to see both of them together, and often they are written in the chain as COOH. They're showing you the carbon oxygen double bond followed by the hydroxide, the OH after it. So here are the rules. You have both a carbonyl and a hydroxyl group, and you're going to change the ending of the carbon chain to oic acid. You put the COOH group, the carboxylic acid group, on carbon number 1, and if there's more than one, you use oxo as the naming. If you have an OH group also added on it, you have hydroxyl. If you have more than one carboxylic group, you change it to dioic acid. And if there's a multiple bond, you have an N-oic acid. So lots of different options here. Again, remember that when you have a carboxylic acid in the chain, you put it at position 1 because it has a hydrogen on it, so it can be the lead piece. So here are some examples. We're going to start in the upper left. We're going to number this 1, 2, 3, 4, 5. So this is a pent. It's pentanoic acid. And it's not needing a number because it's at the 1 position. Looking at the next one on the right, starting here at the carboxylic acid group, 1, 2, 3, 4 is our longest chain. So this would be a butanoic acid. Let's just move over because I'm going to run out of room. Butanoic. And we numbered that chain, but we also have this branch up here. So we have on carbon 2, we have a methyl. So 2-methylbutanoic acid. Looking at the bottom one, we have 2 hydroxyl groups. You have one on the left and one on the right. So it doesn't matter which we start with, 1, 2, 3. So this would be a propanoic acid, but because we have 2 of them, we're going to go propadiodic acid. Now, the only places you could put this would be at the 2 ends, so they're not going to number it. Here are 2 widely known carboxylic acid groups. This one, let's go ahead and number it. We're going to go 1, 2. So we would, in theory, number it ethanoic acid. But if you remember back in one of the previous videos that we learned about functional groups, there were some common names. And when you have 2 carbons, it is this grouping. So it is acetic acid because it has a 2-carbon chain. So this one is also known as acetic acid. That's one of those formic, acetic, butyric kind of things. Looking at the bottom one here, we have 3 different hydroxylic groups here. So if we pick one on the left, so 1, 2, 3, 4, 5, there is a 5-carbon chain here. So in theory, this would be a 5-carbon chain, but what they actually do in this name, this one is actually called citric acid. So how they named this one is they look at the fact that you have 3 carbons between these hydroxyl or the carboxylic acid groups. So they go 1, 2, 3. So they call this a propane, and it has an OH group on carbon 2. So 2 hydroxy propane, and it has a 1, 2, 3 then tricarboxylic acid. Now I looked this one up. I'm not gonna lie, if I saw this structure, I would be calling it citric acid. I don't know that I or many other people would use the IUPAC naming scheme to get the 2-hydroxypropane 1, 2, 3 tricarboxylic acid. In fact, I saw more than one possible name for this, and you'll find that with all the details and all the extra pieces on these functional groups. there is sometimes more than one answer, and you get to the same structure. It's just a matter of what you're calling it.